Hey guys, hope you're enjoying your snow day. What we're going to do is I'm going to give you the answers to last night's homework, which was midterm review sheet 2. And first off, what I'll do is I'll just give you the answers throughout the whole thing. And then whichever ones you have an issue with, you can fast forward and go to those problems. So number 1, the answer was 15 minus 6i. Number 2, x minus 1 squared plus y plus 2 squared equals 9. Number 3 is 11. Number 4, negative parentheses x minus 3, or you could distribute negative x plus 3. Number 5, 5 times radical 5 plus 1 all over 4. Number 6, 190 over 27. Number 7, negative 1 plus minus I rad 6. Number 8, negative 5 is less than x less than 1. Number 9, choice 4. Number 10, negative 2, 1. You can put it in set notation, or you can write it separately. X equals negative 2, x equals 1. Number 11, 1 minus a. Number 12, now this is a big one. So number 12, here we go. Number 12, 32 x to the 5th minus 80 x to the 4y plus 80 x cubed y squared minus 40 x squared y cubed plus 10xy4 minus y to the 5th. It'll take 65.7 years to hit $1 million. 14, choice 3. 15, x squared minus 6x plus 10 equals 0. You must have equal 0 because it's an equation. And finally, 16, choice 2. So now if you had problems with any of those, fast forward to the ones that you have an issue with, or watch the whole thing if you're really not sure about any of it. So here we go. Alright, back to question 1. So I'm going to turn my calculator on. Make sure on your mode you have it set to a plus bi. And it should also be set to degree mode. Not that it's going to really change anything for us today, but keep that habit. So number 1 goes right in the calculator. So you go 3 I is over the decimal, second I, parenthesis, 2I squared minus 5I. Right in the calculator. You could do it by hand, you could distribute, but this is an easy one. Make sure you get it right. So it's 15 minus 6i. Number 2. Well, the circle has this basic structure. Right? The x's and the y's equals the radius squared. Now what you have to remember is the opposite sign. So it's x minus a 1 on the inside, y plus a 2. So that's the 1 and the 2. Now, then you count from here to here. There's 3 spaces. So 3, there's the radius, therefore its radius squared is 9. Number 3, functions. We always start in the back. There's a composition of functions start in the back. So I'm going to plug in 1 right here. So it's going to be 5 with a 1 squared minus a 1. And then you crunch this out. So 5 minus 1, you get a 4. This is what I plug into the g function. So 12 minus 1, the answer is 11. Number 4. This is a multiply and a division. So what we're going to do is we're going to factor, cancel, clean it up. Alright, so let's factor, cancel, clean it up. And since it's a division problem, this one will also become multiplication, but you must flip this back problem, the back part. So x plus 3, x minus 3. Take out of x, x minus 5. Take out of x, 5 minus x. Now, as soon as I say this backwards, I'm thinking -1 trick. X minus 4, x plus 3. And finally, x minus 4 goes downstairs because we flip this one over. And upstairs will be x minus 4, x minus 4. So check your factoring. And now we're going to cancel. So anything upstairs with downstairs. Alright, so remember this -1 trick. So I'm going to put a -1 right here. The x's cancel. X plus 3 cancels x plus 3, x minus 4, x minus 4, another x minus 4, another x minus 4. Now we look to see if there's anything I missed. And it looks pretty good. So clean it up. So it'll be negative parentheses x minus 3. Next one, we're going to rationalize. We use the conjugate. So it's rad 5 plus 1. And distribute the bottom, or foil it out, however you want to call it. So rad 5 is 5. Minus rad 5 plus rad 5 cancel. -1 times 1 is -1. So downstairs I get a 4. Now you could distribute the top. You don't need to distribute the top because this won't cancel and doesn't cancel anything else. So I'm done with this part. Number 6, we're going to evaluate the function at 3. So this is going to be 3 to the -3. So wherever you see x, you plug in 3. Minus 3 to the 0 plus 2 to the 3. Now you could do this in pieces, or you can type it right in the calculator one shot. So I'm just going to punch it in. 3 caret -3 minus 3 caret 0 plus 2 caret 3. And I get 7 and change. I'm going to math frac that, convert it to a fraction, and you get 190 over 27. Now you might see it as a mixed number if you were doing another part. You know, if you look somewhere else. I'm not a fan of mixed numbers, and most of the time we don't use it. But if you actually see this problem somewhere else, they might have said 7 and 1/27. All right, but I'm stick with the mixed fraction. Excuse me, don't do the mixed fraction. Stick with the improper. All right, number 9. What is that? It's a plus bi form. That means either I can do it by completing the square, or I could do it by quadratic formula. So if you actually got it right, try the other way. So quadratic formula is actually harder for this problem. So in quadratic formula, a is 1, b is 2, c is 7. The formula is x equals -b plus minus all over 2a. And then we're just going to substitute. So x equals -2 plus minus radical. 2 squared is 4 minus 4 times 1 times 7 all over 2 times 1, 2. -2 plus minus radical. Clean it up, you get -24 all over 2. Now 24 is really 4 times 6, so -4 times 6, so it's -2 plus minus 2i rad 6 over 2. we look for this triangle to reduce. So you get -1 plus minus I rad 6. Now I said complete the square was easier, so that's formula. And complete the square is actually easier. So here's to complete the square. So x squared plus 2x. Now when you do complete the square, you move the 7 over. So you want x's to one side. So I have -7. I take half this middle too, so that's half of it's a 1. But now if I actually did this 1 squared, there should be a 1 in the back to make this true. And if you add 1 there, you must add 1 over here. So that's how I get this -6 floating around. To get rid of the square, we square root. So it's x plus 1 equals positive negative square root -6. Square root of -6 is I rad 6. So x equals -1 plus minus I rad 6. The exact same answer that we got before. Number 8, you're going to factor this. X plus 5, x minus 1, -5, positive 1. I like to make a number line, -5, 1. So it's a less than, so it's open. And less is going to be shaded in. You can check this by just plugging in a number in between, like a 0, 0, 0. -5 is less than 0, so that's good. So since it's in between, you write like -5 less than x less than 1. Number 9, the roots of this equation are, look, so this is called nature of the roots. So we're talking about discriminant. So they're talking about the formula b squared minus 4ac. And when you look at this problem, a is 2, b is 0, c is -5. Because there's no b value, there's no x in the middle, so that's b is 0. So that's what we're going to use. So it's going to be 0 squared minus 4 times 2 times -5. Crunch this out, we get 40. 40 is non-perfect square. 1 would be negative numbers. Equal is 0. Alright, rational unequal would be perfect squares. 40 is not perfect, therefore it is choice 4. Fraction equals a fraction. I made that other side a fraction. I'm going to cross multiply. So I get 2 equals x times x plus 1. Distribute. And if at any time I'm going too fast, just hit pause. Set this to 0. And what we're doing is solving for x. So I'm going to factor. So I get -2 and positive 1. I go back to the original. The only number that would be bad here would be a -1. So -1 is bad right there. So these are both good answers. So I got -2 and 1. Alright, number 11. Complex fraction. So I'm going to make everything have a little baby fraction, little baby denominators everywhere. I look for the common denominator in this problem. I got a's and 1, so the common denominator is a. I put a in all the numerators. And then we cancel as we go. So a cancels a, so that's 1 minus nothing cancels a squared. A's cancel. I get 1 plus a. Factor cancel clean up. 1 plus a, 1 minus a, over 1 plus a. Those cancel out, and the final answer is 1 minus a. Number 12. Alright, this is, we just actually tested on this. This was the binomial expansion. We used Pascal's triangle. And I'm going to go to row 5 because I have a fifth degree. So 1, 5, 10, 10, 5, 1. Those are my numbers I need. Those are my coefficients to start with. So 1, 5, 10, 10, 5, 1. And then we set up parentheses. And in the first parentheses, the first part, so I get 2 x's. So 2x, 2x all the way down. And the second parenthesis, I put the y's, and now in this case, negative y. So watch that sign. The negative y is going to make it oscillate back and forth, go flip-flop, positive, negative, positive, negative. And the powers on the first one, we start with 5, and it goes 4, 3, 2, 1, 0. And on the other guy, it goes the other way, or they add up to 5. So it'll be 0, 1, 2, 3, 4, 5. And now we actually just go through and do each one. So if you have an issue, I'm going to do the first one, and then I'm just going to write down the other ones. So if you have an issue with this, I do numbers with numbers, and I do letters with letters. So this 5 will go onto both parts, the 2 and the x. So that problem is going to be 1 times 2 to the 5th. And actually, anything to the 0 is a 1. So it's really times 1. You don't have to write that, but hit enter. So I get 32. So that's the number part. That's the coefficient, 32. X to the 5. And we already said the y disappeared. It's a 1, so it just got mushed into that 32. So now I'm just going to put down the other ones, and you just go through, you check yours. So negative 80, x4, y1. And as the 1 goes down, the other one's getting bigger on the powers. Negative 40, x squared, y cubed. Positive 10 x to the first, y to the 4, negative 1, 1, negative y to the 5th. And now we don't leave it like this because now I didn't expand. I did all the pieces. Now to expand it, we write it all out one shot. So 32 x to the 5 minus 80 x to the 4 y plus 80 x cubed y squared, and so forth. And that's our answer. All right. Drew's parents invest this money, so they give us the formula. So that's nice. I want to hit $1 million, so I'm going to set it up. 1 million equals 1,500 times 2 to the power t over 7. And this is a log question. We want to get this exponent down on the ground. We're going to use logarithms. So first off, divide by 1,500. Okay, let's clear the screen out. So 1 million divided by 1,500. So we get 666.6 repeating equals 2 to the t over 7. Now to get the exponent down, I want this whole exponent on the ground. We're going to use logs. So it's going to be, take the log of both sides, 666.6 equals t over 7 log 2. Now, so now it's on the ground, so that's good. But now let me get rid of this log 2 first. Get rid of this. Now notice I'm not rounding anything on my calculator. It's all still there. So what I'm going to do is I'm going to press log answer. So that's log 666, 6 repeating, close parentheses, divided by log 2. I'm going to leave all the decimals in. You don't round until the very end. So now I have 9.3808, you know, keep on going, 21784 equals t over 7. Notice I'm not rounding. And then this is really over 1. So what I can do is just cross multiply. So just multiply this top by 7. So times 7. And I get 65 point, right? So now over here, 65.665752449. Especially on the regions and stuff, you want to show all your work. And then over here, I'm just going to round it 65.7. Because they said 1 decimal, nearest tenth. That's a good question. Number 4, we're going to expand this. We're going to take the log of both sides. And what you need to know is multiply means add in log world, and powers go in front, division is subtract. So they all have a subtraction, so that's the division. Now things to remember, this would go in front, this 2 would go in front, so it should say 2 log C. So these are bad. Number 1 and 2 are bad already. And this should be pluses in between. So number 4 is bad. So the only one that actually makes sense in this problem is choice 3. Write the quadratic equation. You're going to find the sum and the product of the roots. And if you need to, you can use a calculator to find the sum product. So just add them together. And what's nice is the i's cancel, so the sum is just 6. Put over 1. Multiply it out. And if you need a calculator, whatever you wish, I could just 3 times 3 is 9. Plus 3 and minus 3 I cancel out. So that's 9. And this is minus I squared. I know I squared is negative 1, so this is a 10. Or once again, use a calculator. And then remember it's going to be ax squared plus bx plus c equals 0. So a is 1 in this problem, so it's going to be x squared. B is opposite, so it's negative 6x. C, just keep whatever was there, plus 10. Don't forget the equals 0. And finally, the last one, which is not a function. We're looking for x's repeating. So if you see right here on choice 2, double 3s and double 4s, that's bad. This is not a function, so it is choice 2. So that's it. Hopefully this helps. Have a nice day.